Alright, area. Area of a rectangle. Let's see here, x squared minus 3x minus 18 square units. We know the width is x minus 3 units. Write an expression that describes the rectangle's length in units. Well, we know on your average rectangle, area equals length times width, right? We go length times width is equal to area. So here they gave us the area of x squared minus 3x minus 18. And they told us the width is x minus 3, but we don't know what the length is, so we need to factor, right? So this would be width times length equals area. So we need to figure out what the other expression is that represents that. So we need to find two numbers that multiply to negative 18, but add to negative 3. Add to negative 3. So that'd be negative 6 and positive 3, right? So let's see here. Wait, so hold on. These factors need to be x plus 3, x minus 6, and then that would give us x squared minus 6x plus 3x plus 18. That would be x squared minus 3x plus 18. Okay, so this problem was written wrong. This needs to be x plus 3 units. That needs to be x plus 3 units. And so your missing factor would be x minus 6. All you do is just factor this polynomial to find out what both factors are, and this one represents width, and this one represents length. Done and done. Alright, 17. Okay, good. 17 is another one where we can use the calculator. The table below shows various values for x and y. Write an equation that represents the relationship between x and y. So fire up your TI-84, and what you can do is let's go to stat, edit. Oops, let me get my window up there, okay, so you guys can see it. So stat, edit. We can clear these. We can clear lists really easy by pressing clear and then by hitting enter. So let's do that for that one. Clear and then enter. Okay. And now let's put in our values here. So bingo. And what we can do is let's press stat calc down, and okay, well, we need to let's see, write an equation that best describes the relationship between x and y. Well, we want to first test to see whether or not this is a linear relationship or a quadratic relationship. So we need to see if the rate of change was constant through all of this. So change in x here, we added 4, and then to get from here to here, we added 9. Let's see what we did over here. To go from 23 to 11, we subtracted 12. And then to get from here to here, that's at 12. We subtracted 27. All right. So our first change in y over change in x, was equal to negative 12 over 4, which was negative 3. Then our next change in y over our next change in x, the second set we did, was negative 27 divided by 9, which is also negative 3. So we see we have a constant rate of change, which means we have a linear relationship. So we needed to do that to know whether or not to select linreg or quadreg. Okay, so I won't save those changes, and we know now to go down and select linear regression because we found it was a constant rate of change. And so there's our equation, negative 3x plus 5. And instead of doing all that calculation, if you wanted to, you could have just gone to the y equals, turn on the stat plot, and plot the data that we put into our table here. We can plot this data on the graph and see if it comes out as a straight line. So we go to y equals, we turn on that stat plot, and then just press zoom and go all the way down to the bottom to zoom stat. And you see that our data sure does. It lines up in a straight line. And so our equation, again, was negative 3x plus 5. Let's see here. I should probably show you how to do that algebraically also. So we'll use our equation y equals m times the quantity x minus h plus k. So we calculated our slope by taking change in x and change in y. And this change in y was negative 12. This change in x was positive 4. And so change in y over change in x was equal to negative 12 over 4, which equaled negative 3. So there was our slope. So we go y equals negative 3 times x. And let's just choose a random h comma k pair. I'll choose this one. Here's h, here's k. So x plus 2 plus k plus 11. And so let's distribute that 3. So negative 3x minus 6 plus 11, which equals negative 3x plus 5. So that equation will work also, as will this equation, because it didn't tell you what form of the equation it had to be in. Remember, this is called point-slope form, and this one's called slope-intercept form. And these are both valid forms of the equation to write. It doesn't matter which one you write, because they're both they both describe the relationship between x and y accurately, and they're equivalent. Okay, let's move along to 18. Which sequence, or which algebraic expression best represents the relationship between the terms of the following sequence and their position n in the sequence? So here's the position n in the sequence right here. So position 1, 2, 3, 4, 5. So let's see which ones of these works. Let's start with our first one. So so in our first position, so if n were 1, 1 minus 2 would be negative 1. So nope, that does not. So this would be like a function of n, f of n. So if we plug in 1 here, do we get 0? No. Let's go down to b. If we plug in 1 here, we get 1 times 1 squared is 1 times 2 is 2. 2 minus 2 is 0. Okay, so that one would work. Let's try the next one. 2 squared would be 4. 4 times 2, 8. 8 minus 2 is 6. All right, B's looking pretty promising. Let's just rule out C and D. 2 times 1 would be 2. 2 minus 2 would be 0. Okay, so that one works. 2 times 1 would be 2. Let's evaluate this at n equals 2. So 2, if n is 2, 2 times 2 would be 4. 4 minus 2 would be 2. Doesn't equal 6. So C is out of the question. And if 2n squared minus 2 worked, we know that n squared minus 2 definitely won't work. So B is our answer. Alright, let's talk about 19. The volume of a sphere, that's like a basketball, can be found by using the function volume equals 4/3 times pi times radius cubed, where v equals volume and r represents radius. What is the independent quantity of this function? What is the dependent quantity? So if we have our sphere right here, and there's our radius inside of our sphere, what has to change first? Does our volume change in order to change the radius? Or when we change the radius, does our volume change? Well, the radius is our independent variable. Volume is dependent. And you can tell that by the way the equation is written, because we always set our dependent value equal to the expression that contains our independent variable. And you can also ask yourself the question, what depends on what? Well, volume of the sphere depends on the radius. Okay, let's finish up 20.